Hello everyone. In today's session, we are going to cover some topics that is completely related to the motors and sensors. As we have already discussed some things like EV3 or functioning of EV3. So we have already covered all these topics. But today we are going to start discussing the motors, like what is large motor, what is medium motor, right? So we are going to start from the large motor. As you can see on the screen, we have two type of motor. First one is large and second one is medium, and you can differentiate through the design also. Designs are completely different. If you can see on the screen, it's completely looks different. This one, right? And it is completely different. So it's completely two different functions. If I'm talking about the large motor first, so it's a powerful and smart motor. Okay, it is a powerful and a smart motor, and the main thing is it has a built-in rotation sensor. Built-in means already available in this motor with 1 degree accuracy. With 1 degree accuracy, so it can precisely control like how much it moves. We are talking about this one. Okay, so this is a large motor. And even it is usually used as a driving motor in robots. Whatever robots we are preparing, so on these models or on these structures, we are using this motor as a like a driving motor. For example, to move wheels, like I have prepared one structure in which four wheels are there. So I will use this motor for the driving purpose, or I can say to move the those wheels, right? So when using programming blocks like move steering or move tank, we will discuss in the next modules, obviously. But right now we are learning like what actually it is, because we are preparing the designs. We have insert all these things in the model. So that's why we are learning the conceptual things as well. When using programming blocks like a move steering or a move tank, so the large motor can work together with those blocks to move the robot smoothly. Okay, so the main purpose is to provide strong power, like best, I can say best for driving the robot. Okay, now we'll move to the next one. That is, we have a medium motor. Now you can see on the screen, I'm talking about this one. So this is a medium motor, right? If I'm talking about this, so it also has a built-in rotation sensor with 1 degree accuracy, just like a large motor. But the main difference is it is smaller and lighter than the large motor. You can see the difference in size, right? if I'm showing you both the images, then you can see the difference in size. So yes, so this one is smaller and as well as lighter than the large motor. So this is the main difference we have in between. And the most important thing, because of its light weight, it responds faster than the large motor. So this is also the difference in between large motor and medium motor. And it can be programmed to turn off and on, or we can programmed to control speed and control movement by time as well as rotation. So all things are matters. And even like if we are talking about the large motor, so it will work for the driving purpose, for moving the wheels. But if I'm talking about the medium motor, then it will work for turn on and off, and to control the speed and to control movement even by time or by rotation. So all things are comes under the medium motor. It will quite more helpful, right, in various aspects. So the main purpose is to like quick and precise movement, we can say. By the help of medium motor, we can take a quick and precise movements, and best for small attachments like grippers or arms. Like if we are adding extra attachments, small extra attachments, then it will also work. Grabber we have made in the last to last class, right, as a extra attachment. So if we want to give the movement, then in that cases we can use the medium motor as well. And if I'm talking about the motor comparison, then you can see the large motor runs at 160 to 170 rpm with the running torque of 20 cm and a small torque of 40 cm. So it's slower but stronger, right? And if I'm talking, or if I'm considering right now medium motor here, then it runs at 240 to 250 rpm with a running torque of 8 ncm and a small torque of 12 ncm. So it's faster but less powerful, right? And the same thing we have, both motors are auto id supported, right? This is the same thing which we have in the large motor as well as the medium motor also. So these motors we have in the kit, right? So we have also covered the concept of large and medium motor, and even we have two large motors in the kit and one medium motor. Now we'll discuss about the sensors. And first we'll cover the color sensor, because we have lots of sensors, like color sensor we have, gyro sensor we have, sound sensor we have, right, touch sensor we have. So we have multiple sensors in the EV3, and now we will cover one by one. So we are going to start with the color sensor first. As you can see on the screen, this is the color sensor, which looks like that. Yes, this one. So this is the color sensor. So color sensor is a digital sensor, which is used in the Lego EV3 robots. right? It's a digital sensor, or if we are designing the structure, we can use it for the color detection part. It can detect multiple things, like it can detect the color of an object, whatever object in front of the robot, right? And the brightness of light reflected from a surface. It also detects the brightness of light as well, and the brightness of the surrounding lights as well, not the room's light. It will also detect the surrounding lights, because it works with the three were three modes. So I can say the sensor has three working modes. So here you can see the color mode, reflected light intensity mode, or ambient light intensity mode. Three modes we have in this sensor. uh, I will explain you one by one. So I'm taking first color mode. The sensor identifies seven different colors. This sensor identifies seven different colors, or these colors are like black color, can detect blue, green, yellow, red, white, brown, right? And plus one more thing, no color. If there's other color we have, except all these color which I told you right now, like black, blue, green, yellow, red, white, brown. uh, After this, if we have another color, so it will detect as a no color. It will consider as a no color, right? So useful for task like where we can use it, this color sensor. For example, like sorting objects by color. If I need to sort some objects by color, then I can use it, this sensor. If I want to following colored paths, then I can use this sensor. And for example, stopping when it see a specific color, like red means stop. Then in that case also you can use the color sensor, and it will work only by the color mode. Now next one, we have the reflected light intensity, this one. Okay, reflected light intensity means the sensor uses a beam light beam and measure how much of it's reflected back. It gives a value from 0 to very dark to 100 very light. In this manner it will detect the light intensity, and it is very useful in the line follower case. If I'm using the line following to complete any path, or to move in on the mat through the robot structure, so it's very useful, where we can detect the white surface, more light reflected, high value, and black line, less light reflected, that is low value. For example, a robot detects black tape on on the ground and follow it. So in that cases, we can use the reflected light intensity mode. When we learn programming, that time we learn this concept, like how we can detect the path, how we can detect the line through color. Okay, now we have the next mode, that is ambient light intensity mode. So it measures natural light in the environment. So it comes through the surrounding, and it also gives value from 0 dark and 100 bright, and it is used for light based actions. For example, robot moves when light turn on and robot stop when light turn off, right? In that cases only it will work, right? And if I'm giving you some additional point, so like sample rate will be 100 readings per second, that is 1 kilohertz. Very fast sensor, I can say. And for best results, we are using this to keep sensor close to the surface. Do not let it touch the surface and keep it at a right angle to the surface. Right? So if I am going to summarize in a very simple word, so I can say color mode detects which color is seen. And the use cases like sorting by color. And if I'm talking about the reflected light intensity mode, so it detects brightness of a surface, and ambient light mode, it detects light in the room. Okay, so this is all about the color sensor. Now we have a gyro sensor. It's a very powerful sensor in the EV3 kit. Very powerful. Now we'll discuss the role and I can say the functionality of the gyro sensor. But before that, you need to understand it through the picture. What is the difference between the color and what is the difference between the gyro? So it looks like that. You can see small light in front of the sensor. But if I'm talking about the gyro sensor, so it's have these two arrows on the upper part, right? You can see on the screen as well. So this is the gyro sensor. I'm going to highlight it. Yes, this one. Okay. So what is it? So gyro sensor is a digital sensor. It is also a digital sensor, I can say, in Lego EV3. And robot used to measure rotations or turning. So basically, it is used for the to measure the rotation and to measure the turning points. So what does it measure? Gyro sensor detects rotational motions around a single axis, left or right movement. Like if I'm talking about the rotation speed, like how fast the robot is turning in degrees per second. And if I'm talking about the rotation angle, then how far the robot has turned in degrees. Right? For example, if the robot turns right 90-degree, so the sensor reads plus 90. And if it turns left 90-degree, then it reads minus 90-degree. Right? And why it is useful? Why is it useful? Why is it useful? Uh, it helps the robot to turn accurately. I'm explaining you the like why is it useful. So it helps the robot to turn accurately. For example, 90-degree turn in a maze game, you know very well, everyone knows about the maze game. So where we need to take a accurate rotation, there it will work. It turned 90 degree accurately. Because if we are doing without gyro sensor that task, so maybe some error will be there. But if we are using gyro sensor to take a turn accurate in an accurate way, then it will help us more precisely and stay balanced or detect fallings. And it also drives straight even if wheels slip in such cases, right? For example, perfect 90-degree corner turns, and it is keeping a robot direction straight during long drive, and it is also detecting if robot topples over. Okay, so if I'm talking about the area in the area of accuracy, so it can measure rotation very quickly, very quickly, up to 440 degree per second, right? 440 degree per second, correct? And it can achieve plus 3 degree and minus 3 degree accuracy when turning. So it's a very important point. But if I'm talking about this some important points, so when plugging in the gyro sensor, it must be completely still. If the robot is moving while plugging or starting readings, it become wrong. Okay, so always start the robot on the stable surface to get accurate values. This is the main point which we need to keep in our mind. So in case of rotation speed, what gyro sensor does, it measure how fast robot is turning. And in rotation angle, what gyro sensor does, measure how far it turns degrees. And in case of axis, what gyro sensor does, on axis left right rotation only, right? So this is about the gyro sensor. Now we'll discuss about the next sensor we have. Okay, let's move ahead. Now we have a touch sensor. Yes, you can see touch sensor is looking like that. Red color extra part will be here. Through this you can easily like identify from all the sensor like which one is the touch sensor. Okay, so let's discuss about the touch sensor in detail. So if I'm talking about the touch sensor, it's a an analog sensor, not a digital sensor, just like gyro sensor or color sensor. So it's an analog sensor that checks if the robot touches or presses something. If the robot touches or press something, maybe it will touch or maybe it will press. So it can detect three conditions. First one is pressed, second one is released, and third one is bumped. On the basis of three conditions, we can detect any object if we have in front of the robot. So what is the condition of pressed? Like the button is being pushed, and released, the button is not pressed, and bumped, quickly pressed and then fastly released. So these three conditions will be there. Right? And what does it help the robot do? The touch sensor helps the robot understand when it hits or touches something in front of it. For example, a robot moves forward, touches a wall, and then stop. For example, robot touches an object and turn around. And for example, robot detects edge of the table when sensor release, so stop from falling. In such cases, we can use a touch sensor, right? So where is it used in robotics? If I'm telling you, so in case of line ending detection, in case of collision detection, in case of robot battles where pushing opponents will be there, in case of object interaction, and in like pressing buttons. So why is it important? So the sensor gives the robot safety and as well as awareness, like help it avoid damage and even complete task correctly through the help of this sensor. So you can see all these three states as well. So yes, this is a press state. The robot has touched something. It means it is in press state. And released, robot is away from an object. So it means it is in released state. You can choose any mode at the time of the programming, at the time of the coding, right? And the next one is bumped, to quick touch and then release. So you can use any one mode to perform any action through the touch sensor. Okay, so this is all about the touch sensor. Now let's move ahead. We have one more sensor, that is ultrasonic sensor. And you can see it's look like that, like two eyes will be there. We can identify through this mark, right? And it is also a very useful sensor, I can say. So ultrasonic sensor is also a digital sensor, right? But touch sensor is a analog sensor. So ultrasonic sensor is a digital sensor that measures the distance between the robot and an object in front of it. Whatever object we have in the front of the robot, and if we find out the distance between both of them, then we can easily find out the accurate distance through this sensor. Otherwise, we can't do that activity, right? So it works like a bat or a submarine sonar. It sends out sound waves and that we cannot hear. We cannot hear actually. The waves hit an object and the sensor measure how long the sound takes to return. So it calculates the distance. So this is the process through which ultrasonic sensor can detect the distance between the uh, object and by itself. Okay. And what can it measure? What can it measure? Distance can be shown in centimeters or inches. So range in centimeter, we have 3 centimeter to 250 centimeter. Okay, I am going to highlight this. Yes, 3 to 250 centimeter. This one. And range in inches, we have 1 to 99 inches. Okay. Yes. 1 to 99 inches. And if the sensor returns, so 255 centimeter or 100 inches, it means no object is detected in front of it. This is also very important point. Okay, so if I'm talking about, or if I'm telling you, okay, I'm going to tell you about the modes of the ultrasonic sensor. So we have two modes. Like if we have discussed, like for example, touch sensor, we have three states. So in ultrasonic sensor, we have two states or two modes. First one is measure mode and second one is presence mode. So measure mode is steady mode, steady light, or presence mode is blinking light. So steady light function is to measure how far an object is, and blinking light function is to detect another ultrasonic sensor nearby. Okay, so let's discuss like what can robot do with this sensor. So robot can avoid hitting obstacles, sorry, and stop before bumping into walls. For example, if we have any obstacle in front of the robot, then we can avoid to hit, right? And if, for example, if we have a wall, so we can stop before bump to wall, right? And even to follow an object or chase an object, we can use it. To detect intruders or moving objects, and sometime uh, ping louder or faster as an object get closer. For example, if a robot see a wall getting closer, it stops or change direction. So in that cases, we can use ultrasonic sensor as well. And we have multiple areas where we can use ultrasonic sensor, right? Okay, I'm going to erase all the highlight areas. And we have one more EV3 sensor, like infrared sensor and remote infrared beacon. Uh, so this is not a different sensor. These are the modes which we have. Okay, just give me 1 minute. Yes, infrared sensor, and then we have this is a different sensor, infrared sensor, and we have one more sensor that is temperature sensor. So these are the ports for the sensors. As we know, we have ports like 1, 2, 3, and 4. So these are the sensor ports, I can say, right? So let's discuss about the temperature sensor and infrared sensor. Okay. So if I'm talking about first the infrared sensor. So infrared sensor is a digital sensor again that detects infrared lights. It has three main functions, for example, proximity mode, beacon mode, or remote control mode. Okay, here you can see the proximity mode means to measure how close an object is, and it is similar to the ultrasonic sensor but uses infrared light instead of sound to detect the to find out to measure the distance. It's completely looks like a ultrasonic sensor and works also look like a ultrasonic sensor. The major difference in between is uh, it uses infrared lights instead of sound only. It can detect motion too. This is the main advantage of this sensor. For example, robots stop, and if something gets too close in front of it, we can use it, right? It can also help us to detect. And the second mode is beacon mode. It works with the EV3 IR beacon remote. It helps the robot to follow the remote control signals. For example, make your robot follow you like a pet robot. Okay, in that case, it will help us. And the third is remote control mode. It receive button signals from the EV3 IR remote, and robot can be driven wirelessly in that case. For example, control your robot like a RC cars. Okay, in that case, it will also help us. Now, if I'm talking about the temperature sensor, okay. So, important note is like Lego EV3 does not include a built-in temperature sensor in the basic kit. This is the main important point. But external temperature sensor for from high technique or vernier can be used with EV3. We can use it, but there's no temperature sensor is available in the kits. Okay, so it can measure heat of surrounding, for example, in degree, for example, in Fahrenheit, or temperature of object or liquids. Okay, in that cases, we are using this. Why temperature sensor is useful in some STEM experiments like environmental data logging, and in some smart home simulations like AC, heater automation. In that cases, we can use it. Okay. The most important thing is it is not included in the kit. Infrared sensor will be there. Infrared sensor is available in the EV3 kits, but temperature sensor is not included in the kits. We can add additionally, we can add externally on the needed basis. Okay. Now, connecting sensor and motors, we have already discussed this part because we have two types of ports. Ports 1, 2, 3, 4. These are the ports we have. So these are the sensor ports where we can attach touch sensor, gyro sensor, temperature sensor, color sensor, ultrasonic sensor, infrared sensor. We can add it, right, on these ports according to our requirements. And the most important thing, if we are adding temperature sensor, because it's the additional sensor, so it is not supported in the EV3 programming, we can help another programming. We can take help from the another software, right? Now, next is we have some ports like A, B, C, and D. A, B, C, and D. So these are the motor ports. Okay, like port A, port B, and C for two large motor, port A is for the medium motor, and port D for the large motor. We can make a that kind of combination as well. to attach the motors or the sensors, right? So these are the process for connecting sensors and motor. So we have covered motor section as well as sensor section. I hope all things are clear to you.